All right. So, I think beauty is in the eye of the beholder, right? And so when you ask to simplify a mathematical expression, it is somewhat a question of aesthetics. How do we divide fractions? What's the rule? Multiply by the what? Reciprocal, right? So this is, oh wait a minute, what's 18 over 2? That's just 9, right? What's x to the 8th over x cubed? That's what? So I have 9x to the 5th. That's the first thing, right? And then I'm multiplying by the reciprocal, which is 6x. I won't try to simplify the second one. 6x cubed over 81x squared. X cubed, 81x, yeah. You're like, you could have simplified that. I know, I'm sorry, I just didn't. Listen, there's what do you got, 54? Let me write it this way. 9 times 6, x to the 5th times x cubed is x to the 8th. You're like, I wrote my work a different way. Hey, more power to you. There's more than one way to write the work here, for sure. We should all agree on the answer. There's a 9 that cancels, right? X to the 8th over x reduces to what? X to the 7th, yeah? So we've got 6/9 is what? That's 2/3. So we get 2/3 x to the power 7 for that one.
So with example 17, can you use any of those boxed answers, or is it just like the...
I would give any of the boxed answers the same credit like on the test,
Okay.
but my labs might be looking for the middle answer, yeah.
Okay.
I'm not sure how big their answer pool is. They usually have like an answer pool of correct answers, yeah.
So you pulled out the 15, that's why the 60 is not there.
Yep.
Okay.
Mm-hmm. Yeah, so we look for the greatest common factor I can pull out there.
My labs is actually looking for specific on a bunch of them. It told me I had the correct answer, but not the right.
Oh, it tells you have the correct answer, but not the right answer?
Yeah. It says, oh, you
Yeah, okay.
it's correct, it's just not in the right format.
In the right format? Oh, okay, well. So let's do this one here. So we can factor an 8 out, right? This is 8 times x minus 6. And downstairs we've got 2 times x minus 8, right? So that's just this term here. And we're dividing, so we multiply by the reciprocal, right? So we multiply by the x squared minus 4x minus 32 divided by x squared minus 36. So so we're going to need to factor those, right, in order to make progress. 8 over, hey, that's easy. 8 over 2 is just 4. So there's a 4 out front, right? Just leave that out there. Then we've got x minus 6 over x minus 8. Great. That's the part that's in red, right? This is the red part. Now, the other part I'll do in blue. X squared minus 4x minus 32. That factors into x minus 8. Wait, no. How do you factor that? 32 is 4 times 8. Oh, so it should be minus 8 and plus 4. You can multiply that out. You get minus 8x plus 4x. That's a minus 4x. So the numerator factors to x squared minus 4x minus 32. Great. Downstairs, we have difference of squares. That's easier. That's x minus 6 times x plus 6. Going a little bit fast here, I think it would take you guys about 5 minutes to process this problem in real time, right? I just factored like it was nothing. Not all of you are there yet. If you're not like, I didn't see that immediately, that's okay. That's why you need to do the homework this week, right? Anyway, so this guy cancels with that, right? And this x minus 8 cancels with this x minus 8. And anything else cancel? Nope. So there it is. We have 4 times x plus 4 divided by x plus 6. There you have it. That's that one. I think example 19 is, probably the hardest problem we've worked so far. Oh, well, that's not true. I think the factoring problems where the coefficient that leads is not 1, when it's like a 6x squared or a 5x squared, I think those are the hardest problems. You know, figuring out how those split up, that's a pain. Granted. See here, move along. Ah, here they are. That brings us to the last section here, which is solving linear equations. Let's see here. Put us so first problem will work will be 5 times 5x plus 9 equals to 13 minus x plus 7. The next one that'll work will be 0.2x minus 0.4 equal to 0.1x plus 6. The third problem will work. There'll be solve C equals to 1/4 times 1/4 times F times S plus K for S. All right. Now, I'm sorry, this section's getting a little bit shortchanged in this section. I will probably end up spending a little bit longer time on this material in like one of the Monday, Wednesday, Friday sections. So once I figure out which section is best, I'll send you guys a like announcement tomorrow saying, hey, if you want to see more examples of this, look at the Friday lecture, okay? Unfortunately, like what happened this week is I spent too long talking about the introduction on Tuesday, so we're just kind of getting back. And also I got burnt by Wards Road traffic Tuesday. I think these problems, though, you'd probably rather work these than the last 10 examples we've done, right? Am I wrong? How do you solve these? What do? We isolate x, right? And see what happens. So like this one, we get 25x plus 45 equals to 13 minus x minus 7. So this gives me what? 26x equals to what? Minus 7, 13 minus 7 minus 45. Which gives me what? I get 26x equals to, what is that? Minus 52. I gotta think through this. 13 minus 7 is 6. So I think that's minus 39, isn't it? So what's x equal to? Minus 39 over 26, right? Which, by the way, is minus 3 times 13 over 2 times 13. So therefore, the answer is x is equal to minus 3/2. So this equation is consistent. Consistent means it makes sense, right? It's not an identity, because it's conditional. It's only true if what? If x is equal to minus 3/2. How would you treat this equation here? What would you do? I'll tell you what I do. When I see decimals in a problem like this, I multiply by a power of 10 to make everything turn into whole numbers. So this one, I just multiply by 10. If we multiply this by 10, right, we get what? We get 2x minus 4 equals to x plus 60, which gives me that x is equal to 64. Because if I subtract x from both sides, 2x minus x is x, and 60 plus 4 is 64. X is 64. Again, this is consistent. It's conditional. It's only true. This equation is only true if x is equal to 64. Example 22, how would you solve for s? There's about like 3 symbolic problems at the end of your homework, okay? So these ones, you just isolate the thing you're trying to solve, right? So we do multiply by 4, so I get 4c is equal to f times s plus f times k, right? So I just distributed this out, right? I'm trying to isolate s, so I want to subtract the f times k to the other side. I get 4c minus f times k equals to f times s. Whoever wrote this problem is evil. S is equal to 4c minus f times k divided by f. I want to give you two more examples, really quick, just so we have the language in front of us. Three x plus 1 equals to 3x plus 2. That'd be example 23 rather. Example 24, x plus 1 equals to x, this is really silly, but x plus 1. These are also linear equations. One of them is what's called an identity, and one of them is inconsistent. Right? Inconsistent means there's no possible choice of x which makes it make sense, right? This one here, what happens when you subtract 3x from both sides? What do you get? Subtract 3x from both sides. Some of you, as I wrote this, were like, oh, finally. Why didn't you write the last 3 examples like that, right? You guys want to work vertically? Go for it. I also sometimes work horizontally. That's how I think. If you don't like that and it's confusing you, and I'm not trying to make up for lost time on Tuesday, just ask a question and I'll do it vertically like this. But what we get here is 1 equals to 2. Is 1 equal to 2? No, that's nonsense, right? This is inconsistent. So this is inconsistent. There is no choice inconsistent equation, right? This one here, x plus 1 equals to x plus 1, right? So this, if you subtract x plus 1 from both sides, you get 0 equals to 0. If you can take the equation you have and manipulate it to get 0 equals 0, independent of what x is, this is what's called an identity. So the solution set for an identity is all real numbers. The solution set for examples 20 and 21 was just the set just containing the number. I'm mentioning these words because these words are also in your homework, but it's not, email me if you get stuck. I will try to send you guys a link to the other section where I talk about this in a little bit less hurried fashion. So, sorry about that.